Good evening everyone, it's Paul Daniels here again. Yes, it's close to midnight yet again. I should just name myself Midnight Fixer or something, I don't know. So anyway, let's see. Tonight I've got a machine that's come in and apparently just doesn't turn on. So I'm hoping it's going to be something quick and easy. With these DELL machines, it's either going to be the power supply or one other little trick that I find often happens, but we'll see if it is this. And if it is the trick, it should be over in a couple of minutes. You watch, it's probably not going to be that. Alright, just put this panel over here. Let's see, I'm sorry I've got the fan on tonight. I'll try and put a audio filter in to knock out the worst of the squeal. But even though it's almost midnight, it's still quite hot here, so you're just going to have to suffer with me. Alright, let's see. Well, I guess the first thing I should try is actually hook it up and power it on. That screen in, keyboard, mouse. I find using these wireless keyboard mice to save me a lot of drama in the workshop. I've got about 6 of these. They're all uniquely coded, so you can have them all running at the same time. They don't interfere with each other. They're just really convenient. Just plug in one USB stick and you're on your way. Let's see, here we go. We have no fan spin and definitely no light. Got nothing there. Alright. Unplugged. Let's knock this front panel off. Nice and easy. The thing I want to get to is not as easy to access at the moment. What? How have they got this fan on? I'm not even gonna... Thank you, DELL, for making it interesting. Oops, sorry about that. Do I want to take that off? Since we can't use that, we'll get those out of the way. Let's see. Oh, you really did want to be removed there. This is the fun thing about PCs, is no matter how many you do, there's always one that's going to throw something different at you every single time. Can I get to what I want? I can. Alright. Need my plastic spudger. And you're not going to be able to see this because I'm not moving the camera. Yeah, maybe I can show you. Alright, but basically what happens is, on some of these main boards, the CMOS battery in there, if that goes flat to a certain point, it will cause the machine to just shut down, show no power, nothing. Now I only found this out by accident once, a couple of years ago, and that was after I'd written off a machine completely. Needless to say, I did tell the person after I discovered that, and we got them back up and running again. But it was a bit embarrassing, and certainly not something you'd expect to be caused by the CMOS battery, especially when you've just lost it in the case. Oh, there we go. Alright. Alrighty. Let's see if we've got a change of tune. Watch, it probably won't be this. Ah, no win. Alright, well in that case, I guess we'll be looking at power supply, most likely. Well, I had hoped that was going to be a quick one for you guys. I'm going to put a replacement battery in, just in case. If I can remember where I put those. I've been cleaning up the workshop, and as a consequence everything's not where I'm normally used to. Not that I'm the most organised person in this workshop. Most of the time it's just a mad rush to get jobs finished. Okay. Yeah, this is how I buy my CMOS batteries. I actually have a couple of stacks of these, so I usually buy them in 100 lots. It's just one of those things that it's easy to change out when you can, especially with laptops when you're wrong way, pull the wrong way. There we go. Okay, there. Okay, that's good. That's good. Oh, well, look at that. That kicked and we're up. Yeah. What are you complaining about? Screen input. 2 beeps. Lots of 2 beeps. Give me something on the screen. I know you can't see the screen. Should be digital input, analog. For some reason I'm not getting anything on the screen. So we do have a secondary issue here. That or it's just... let's try again. Still nothing. Well, the CMOS trick still applies, even if this doesn't come up. So definitely if you get a machine that's showing absolutely no life whatsoever, just try to replace the battery. Doesn't really make a lot of sense, but it definitely happens more often than not. And it seems to happen more with brand name machines than it does with generics. So I don't know whether there's something deliberate going on there, but the pattern's certainly there. I'll just change my memory in a different slot just in case I got memory errors, but it would be beeping if I had memory problems usually. I really don't know why I'm not getting anything on screen here. The screen's definitely working. I used it the other night. No. No. Let's try to pop that battery again. Get you out in my way. Battery popped. Oh, hello. We've got something down here. Where are you? We've got a little bit of crusty stuff just down here. Could have just been random bug crap. So find out. Alright, let's try this again. It should beep again. Interesting, it didn't beep again. Come on, computer, why aren't you posting? I'm going to go get another power supply, just a normal ATX one. Oh, crikey, that's hard. Yeah, I'm just going to get another ATX power supply, plug it in, see if there's any improvement. See how we go now. Well, the result's the same. It's interesting. It's actually, see, it's cycling up and down. I've seen this behaviour before, but I'm sure there's a multitude of reasons for it. See if it's trying to read. Plug this in. See if I can see it flashing. I've got no flashes, which means it's not really getting to anywhere near the bars. Well, yeah, I can actually see what's probably wrong here. That little piece of junk, it has damaged the circuit board. I can see one of the resistors, in this case R449, has blown itself off the board a bit. So that will be why it's dead. Now, the downside is I've got to decide now whether it's worth fixing this up. What is this? It's an i3. I don't know which i3 it is. So it's not a bad build per se. I'd say it's definitely worth trying to repair, especially since the fault is quite clear. I'm gonna put a picture of this into the video so you can actually see, and I'll try and get the light just below the just below the CMOS battery. This isn't gonna. Anyway, there are. Let me get the pointer. Okay, trying to get the light to look good here. There's a resistor here, and it's lost half of its cap. It's got no cap on one end. It's been corroded out, and the junk that I found was just attached to there. So something's landed just in this area here and caused it to eat away. It looks like that's the only fault I can directly see. Oh, there's some other crap around here too, actually. Just here, there's some more crap. What else? Well, it looks what I would say some bug, probably a little moth or something, has gone along and just done little deposits here and there. Looks like this one's okay. That was just on the conformal coating, so no big loss there. But this one definitely needs replacing. I have no idea what that resistor value is going to be. I'm going to have to look up this board, and it's a what is this? DRV75R Pine Valley motherboard. Well, hopefully I can find that one, and if I can, I'll get this video up, and yeah, hopefully we'll get it back together. Okay, I finally decided I'd take the main board out. I couldn't find any schematics, board views, anything that was close to being able to help me with this particular problem. I did measure the voltage before when it was running and found that I've actually got 3.3 coming into this regulator, and it's putting 2.5 out, but that's because it's got a blown resistor down there, so the true value is not going to be that. Now, I can tell by looking at the board that it's actually this trace here, this bottom one, thick one. So it's going to be coming in around about this area here somewhere. And if I can find the pin on the socket that it's connected to, then I can go through and find it on another schematic or something and see what I'm looking at. Hopefully it's something not too generic, hopefully it's something that's obvious. Okay, I've just got my meter set up to continuity. They're pretty quick to respond, this one. Some of the cheaper meters take a second or two before they beep, but this one's very quick. Alright, here we go. So all I'm going to do is just gently, because I don't want to damage these pins, run my pin here across. So Okay, I think that first little tiny bit was probably a capacitor to ground, or something like that. Okay, we got one. And I can't hold the probe. These are very small probes. I wish they actually had a bigger handle to grab onto. Not that one. Okay, so it's the second one in on the final row of this inverted L section here. We'll see what that is, and hopefully we've got something. Alright, it turns out this is AK11, and it's also connected to AK12, and in this case it turns out it's for the VCC PLL, so phase lock loop. It's supposed to be running at 1.8 volt from what I can see. So we've got 3.3 coming into this. We'll have to calculate what we need to get 1.8. I can either remove the resistor and create my own pair here. Mind you, these are 0402 resistors, and I don't have a huge stock of different varieties. I've got plenty of 0603, which I can fit on there, but it's a little bit oversized. The other option is I can just lift the leg here and then measure the resistor. I can't measure the resistor while that leg is attached because that's going to influence the value. Once that leg's off, yeah, I'll be able to get it. So I might try that method. Hopefully I don't botch the regulator, but if I do, I've got plenty of those sort of regulators lying around. So let's get the soldering on here and see what we can do. You're going to fit under there. Maybe I should use tweezers. Well, guess what? Broke it. Crap. Oh well, like I said, I do have plenty of others. Still, that is annoying. And I've actually now got to get the whole bloody thing off. Ah, crap. Hopefully I won't blow off that one resistor that is actually still intact. But if I do, it's okay, I'll just create my own divider. Judging from the various schematics I've seen, they tend to run these with quite a fair bit of bleed current. Not sure why, but they do. Yeah, but these things are going to take a while. The main reason why these take a long time is because the epoxy casing is just so thick, it's hard for the air to... Yeah, you got to get the heat to penetrate through it and then into the board. There we go. And who says you need a super expensive hot air station? Look at that, that got that under a reasonable time. Alright, it's going to be my hot air here. I have to make sure that the curtain doesn't burn. I'd love to know actually what caused this. I'm guessing it was some bug with very caustic poop. Alright. I guess now is a good time to measure the resistance. Let's see. Resistance mode. I'm expecting something in the hundreds. Yep, 124. Right, and I'll have to find myself another regulator. Like I said, I've got a bunch of those. What is curious is that these are actually 3 amp rated DPAC 2 regulators, but in reality, there is no way they can cope with 3 amps. You're lucky if they'll take 800 milliamps, 1 amp, before they start getting uncomfortable. Even with that level of ground planing, they just can't cope. When I used to do the model aircraft stuff, using this size regulator. It's very popular. I actually still manufacture them occasionally for a 1 amp class linear regulator from 2S LiPo down to 5 volts or 5.5 volts, and there is no way they can take 3 amps load, not unless you've got some sort of massive heat sink on them or something like that. So yeah, I'd be pretty confident putting a 1 amp grade unit back on there. It's all just down to marketing and how they decide they're going to fudge the figures to give them that sort of level. For the most part, yeah, there is some degree perhaps of extra durability built into them, but for the most part it's just fudging of the figures. You look at any of the IRF TO220 MOSFETs and some of the ridiculous current figures they post with those, it's a joke. Anyway, I'll go work out what resistors I need, and I'll get myself another regulator, make sure it actually matches that pin out. And after all that, I was about to say all this, after all that, I still can't be guaranteed this is even going to work, because if 2.5 volts did go to the CPU on those pins, that VCC PLL, I don't know if that's going to work anymore. The CPU could be blown for all I know. I'm not sure if I've got any other 1155 socket CPUs around. I may have something on another machine. I'll have a look through my CPU collection. Yeah, we'll just have to wait and see. But at least we've worked out now what we can do with that regulator. Probably no one else in the world's ever going to need that, but at least we worked it out. Alright, sorry for the break, but unfortunately the camera died on me the last time while I was fixing it. Needless to say, we've managed to fix the board. It ended up, I was able to work out the resistor values for the regulator, replace the regulator with one of my ones that I already had in stock that had the same pin out and also same package, and I got myself a nice steady 1.79 volts on the output, plugged everything back in, and it's all running good. But what was happening after this is it was shutting down sort of anything between 5 and 10 minutes. I thought, oh great, you know, maybe there's more faults on the board, because I did find that there were bits of junk again over here, and this is the main I/O controller. Back over here, which I think was the audio controller over here, and there was a little bit down at the base of the DDR socket. So yeah, the bits of junk around, I thought, oh, you know, even after cleaning those up and giving them a bit of a flux wash and heat, I should say, and then washing them, the board was still playing up. Fortunately, as the last desperate measure, I tried changing over to a different power supply, and now it seems to be running just fine. I'm currently up for 46 minutes runtime. I've got the CPU running flat out 100%. We're sitting on 55 degrees centigrade. It's going quite well. So it would look like I've now also got a power supply problem to fix up. I did look inside it. There was a little bit of corrosion on one of the legs of the opto couplers on the daughter controller board. I cleaned that up. It's still doing that. It is behaving more like it's a decoupling cap failing on me. There's about 5 or 6 in there, which are some sort of dodgy brand that I seem to always pull out. I just can't seem to recall it off the top of my head again. So I may just open it up, replace the caps, see how it goes. I know that this machine isn't worth the cost of me replacing that power supply. I can't get them for anything less than about $90, $100. So since I've got a bit of time on my hands at the moment, I might just open it up, change the caps. If I'm lucky, it'll work. If I'm not, I'll just put this on the shelf, and maybe one day in the future another machine will come in with a completely destroyed main board and I'll be able to use this power supply. So yeah, in summary, the board is working. It is fixed. After all that, it's a bit of a drama trying to find the details we wanted. That's the nature of PC motherboards. You really do have a hard time getting the specs, the schematic, the board views. So they're very easy to waste a lot of time on. They're not a great return on time investment, but if you don't have anything else to do, then sure, give it a shot. If you want to find the best chance to get information, places like badcaps.net, whatnot, aren't a bad place to start asking questions. Anyway, thanks for watching, and I'll see you next time.